Okay, here we are with AP Chemistry Summer Assignment, Chapter 2. Chapter 1, Part 2. Problem number 23 said to make a graph, or at least think about a graph, of the temperature of Fahrenheit versus Celsius. And so you were also then to consider what would the slope and the y-intercept be. So you remember this equation. Where's my pen here to write with? This equation for a line, one of the equations of a line that you're familiar with looking at, y equals mx plus b, where m is the slope and b is the y-intercept. Now, if you also think about the conversion factor for converting Celsius to Fahrenheit, you would see that it seems to match this. In other words, here we have a slope and here we have a y-intercept, and we have y and x. So if we make a graph with temperature Celsius on the x-axis and Fahrenheit on the y-axis, we see something like this. And I just went into Excel. Maybe some of you did this same process, generated some temperatures, formed a graph, and here we see y equals 1.8. That's the same as 9/5, x plus 32. So as you're working on AP chemistry problems, you want to be looking for these kind of relationships that deal with slope and y-intercept in a line equation. Number 23, the second part, was looking at Celsius and Kelvin, and so here you see that the slope is just 1 because the relationship between Celsius and Kelvin, remember, is that 1 degree Celsius, that much change, is equal to 1 Kelvin, and so the slope, of course, then is just 1. So slope is 1, and the y-intercept is negative 273 because 0 Kelvin is negative 273 degrees Celsius. And you may have seen that if you graphed a few points in Excel and then told Excel to find the equation of that line that you generated. Number 31 is looking at sig figs in addition, and you may need to slow this tape down, this video down, and read that a little bit more. But basically here in A, we're looking at the least significant answer in the first decimal place. So we've just underlined that here in our intermediate answer. That's where we need to round to. Of course, this is going to be make it round up, so we round up to 641.0. Here, our intermediate answer is going to have to be rounded to the third decimal place. Right here, we look and see that this 1 is not going to require us to round to 7, so we'll just cut it right off at 1.327. Moving on to C, we see our least significant digit here in the second decimal place, so we're going to round this to the second decimal place. The only thing tricky about D is that it has to do with exponents, and so they've made the exponents the same here so that it's easier to more clearly see the significant digits. So we rounded it to the second decimal place, and this is how they wrote the answer. You could have written the answer 3.215 times 10 to the 3, but I just think that takes a little bit extra writing, but you're certainly welcome to do that if you wish. The only tricky part about E is to recognize that the uncertain digit is in the third decimal place, so we actually have to add a third decimal place to the answer to have the right number of sig figs. And by the way, sig figs are important in AP chemistry problems and on the AP chemistry test. So watch those. Number 37, this was actually number 37A, I think, was not on the assignment, but I just wanted to remind you to take a quick glance at that, because those kind of problems will certainly be coming up in the future as we work on tests or future assignments. And so remember to use the factor label method or dimensional analysis to make sure the units come out in the units you're looking for. In this particular case, it was supposed to be in pounds and ounces, so we took the 0.62 pounds and continued on to convert those into ounces and rounded that to 8 pounds 10 ounces. In the second part of A, you were supposed to find the length of this baby to the closest. It actually didn't say 0.25 inches, it said the closest 1/4 of an inch. And you really can't use 0.25 because that has too many sig figs. So the baby was 20 and 1/4 inch. 37B was on the assignment, and once again we're looking carefully at the units, and I guess I should have had a 1 here, but the miles cancel out and give us kilometers, and then we converted from kilometers to meters, and hopefully you didn't have any difficulty with that. Number 48 I think was a really interesting question. It's about a dosage of acetaminophen. That is the generic name for the non-aspirin pain reliever that's in Tylenol. And if you use the elixir for kids, it's 80 milligrams in every half teaspoon. So the question is, if you give it 1.5 teaspoons, if that's the dosage for children that weigh 24 to 35 pounds, what's the range in dosage if you express that in milligrams per kilogram? So we'll want to be sure that our units come out in milligrams per kilogram. And I started this in a couple steps here, but actually the entire answer is encompassed here. Here's our 1.5 teaspoons. Here's our dosage that was on the bottle, 80 milligrams of acetaminophen for half teaspoon. And here's the weight of our child, 24 pounds. So if we're looking carefully at the units, the pounds cancel out and we're left in milligrams of acetaminophen per kilogram of body weight. And that's the units we needed to have, milligrams per kilogram. And so you'll have a range here of this milligrams per kilogram to this milligrams per kilogram, and that's the range of dosage for children weighing 24 to 35 pounds, but expressed in milligrams per kilogram. Are we to number 60 already? Only 2 problems left in the Chapter 1 summer assignment. And it is really a fairly easy problem. We have 11.2 milliliters of water in a graduated cylinder, and we dump in 5.25 grams of silver. So of course that's going to make this water level come up, right? Well, how much is it going to make it rise? Well, we are given that silver has a density of 10.5 grams per milliliter. So if we add the original volume of the water to the volume of the silver, we should be able to calculate the final volume of the liquid in the graduated cylinder. Number 66, we're looking for the length of this copper wire. We know the diameter of the copper wire, we know the density of the copper wire, and we know its mass. That's the data we're given. Of course, we can easily calculate the volume using the volume and the density, and making sure our dimensional analysis works to give us centimeters cubed. We know now this volume, we know pi, of course, we know the radius, so we can find the length of this wire. That's the volume, the formula for finding volume of a cylinder. So the volume of the cylinder is pi times the radius squared times its length. So we should be able to find the length since we know the volume and we want to be sure and use the half of the diameter to get the radius. So check and see if you came up with 5.1 times 10 to the 3 centimeters in length, and double check to, let's see, do I have the right number of sig figs here? We should have, yep, 2 sig figs, because we have our diameter of the wire in 2 sig figs. Pretty long piece of wire.